Welcome everyone. Thank you for attending this session. So this is about Query Store in depth. And my name is Ola Hallengren, and I work as a database architect in Saxo Bank in Copenhagen. And thank you to all the sponsors. So here's some more information about me. If you have any questions after the session, please feel free to send me an email to this address. And here's also my website. Okay, about Query Store. First, I wanted to ask how many are actually using Query Store in production? I'm not sure if there's like a survey feature in this GoToMeeting. Is there? Okay, so I will try to give a quick overview to Query Store, and also look at how we can use Query Store in different troubleshooting scenarios or troubleshooting different problems. And also take a closer look, how is Query Store working in different scenarios? And also which tools we can use to analyze the Query Store data. And we will look at Power BI and also Excel Powerpivot. And I will make some demos here as well. Okay, so what's Query Store? So Microsoft, they are marketing it as the flight recorder in SQL Server. And it's capturing queries, plans, runtime statistics, meaning how many executions, what was the CPU, execution time, and so on. And also weight statistics starting in 2017. And it's very easy to enable, just an auto database command. And all the data is stored inside the user database. So if you do a failover or backup restore or anything, then it comes through the database. So I mentioned before what information is in Query Store. So we'll take a closer look at that, and I'll also look at what information is not in Query Store. So we have like two parts. We have one part that's a bit lighter blue here. That is the queries, the query text, and the query plans. And this information is, you can say, it's stored at the first execution in Query Store. And then you have the runtime statistics and the weight statistics. And that is like stored, you can say, continuously. And in Query Store, it's working with something called intervals. And by default, the interval is 1 hour. So you can see like hour by hour, you can see how many executions, what was the CPU, number of executions, and so on. And also one important thing, that it is stored by execution type. So you can see if it's regular, meaning successful executions, aborted executions, or if there was some kind of errors. Now let's see what information is not in Query Store, and we might need to use other information to correlate the data with Query Store. So one important thing is that Query Store does not have any information about who executed a query. There's no login name, no host name, no application name. Query Store is like you can say the plan cache. It has the information about all the queries and the plans, but no information about who executed it. And sometimes that might make the troubleshooting a little bit difficult. Another thing is that the plans that you see in Query Store, they do not have any, you can call runtime information. No information like actual number of rows or actual number of batches. And that's of course because the plan is only stored once, and the actual number of rows and batches and so on, they're of course different for each executions. So you can say it's like the estimated plan, similar information. And then of course, what we have in Query Store is aggregated information. you cannot see anything about individual executions. You only have like averages and mean and max and so on. If you want to actually see information about individual query execution, then you have to use trace or extended events. Now let's take a little bit closer look at different ways of using Query Store. So it's like you can say high level is two ways of using it. So one level is one way is that you're starting at like what I call a macro level. You're looking at the big picture to start with. Maybe you have a server that's very high resource utilization, maybe 100% CPU, maybe a lot of TempDB usage, and then you want to find out about what is actually using the resources and how can you optimize it. Another starting point is that you have a very specific query that is timing out, and that could be in a critical incident. Maybe the load on the server is not very high, but you have a very critical query that is timing out. So a little bit two different ways of using Query Store. And we'll take a bit closer look here how we can do that. So if we start with you can say high resource utilization scenario on a server. Then it's starting out by maybe you're getting alert from maybe performance counters that let's say that the CPU is high, processor time total is high. And then what do you do? Then you go into Query Store and finds, okay, which queries is using most of the resources. Maybe it's only one query that maybe got a bad plan or whatever, or the application starting executing the query a lot more frequently than before, or what. But it's starting with some kind of incident with high resource utilization, and then you go into Query Store and find out what's using the resources. And then of course you can continue to look at the query plan, you can look at the runtime statistics, wait statistics, and so on. But still here, you have no information about who executed it. Let's say that there was, one query that suddenly is executing a lot more than before. Who is actually doing it? You cannot see that in Query Store. So here you need to look at other places. And one place to look is that if you have data from DMX request and DMX accessions, then you can actually correlate that data with the data from Query Store. And I will show you how you do that a bit later. So the other scenario here is that you are starting out by a single query, store procedure, that is running slow, and it's a very critical incident. Overall, the resource utilization not that high on the server, but this query is timing out, and you need to fix it. So then the first step is that you need to find the query ID. And that's sometimes not so easy because let's say that this was a report, an ad hoc query, maybe in a report in this critical incident. Maybe you don't know exact query. Maybe you only have an event from the application, but you don't know the exact query. And then it could go like the other way around. If you have the data from DMX request, DMX accessions, then you can start there to find the data. I mean, find who executing it and so on. And then you can go into Query Store and find which is the query ID. And once you find it in the Query Store, then you continue to analyze execution plan, runtime statistics, and wait statistics. So you see there's like two starting points. Either you start by the overall high resource utilization, and then you go from there, or you start by a specific incident that some query or some store procedure in your application is timing out. And then the question is, how do you correlate it? How do you correlate the data from Query Store and with data from DMVs like DMX request and DMX accessions? So you see here that here you have Query Store query, and here you have Query Store text. Now you see that there is something here called statement SQL handle in Query Store text. And here we have in Query Store query, there's something called context settings ID. And these two columns you actually also have here in DMX requests. So you see here, statement SQL handle and the statement context ID. They're just named a little bit differently, or one of them, but it's the same thing. So what you can do then is that, let's say that all you know is maybe the host name, or let's say that the host name and the timestamp and login name, for example. And let's say that you collect this data continuously using some monitoring system, or you build something yourself. Then you can start out here. You start with find the data in DMX sessions, and then you go from here on the session ID over here, and then you have the statement SQL handle and the statement context ID, and you can continue over to query store. And also you can do the other way around. If you have something in query store and you want to find out, okay, who's actually executing it, then you can use those two columns and go in the other direction. And therefore, it's really important that you're collecting data from these two DMVs, either through some vendor monitoring system or through some ad hoc collection, also built-in home-built monitoring system. Now let's see how to do that. So here we had a very critical report that was timing out, and you want to find out what happened. So now let's see how you can do that. So I prepared a demo here. Any questions so far? So there's a question here, does activation of query store affect significantly SQL Server performance? There are a few percent performance overhead, so not much. You can say that the overhead is higher if you have ad hoc workloads with large number of queries, but overall the performance overhead for most scenarios is very small. I can say that we have enabled it for all databases in the bank where I work. And there has been some issues in the past. There was one issue we could notice some overhead, and we reported it to Microsoft and support case, and they fixed it. That was in 2016, I think. But overall, I think for 99% of the scenarios, it's very low overhead. Any other questions? Okay, let's try to do this demo here. So what I will do now is that I will execute a query. So I start this one here. And then we will pretend that this one is timing out, and then I want to find it in query store. So first I want to show here that just for the demo here, I'm collecting data from DMX accessions and DMX requests. And this is just a simple way of doing it. I mean, with a local job, I think in the real world, it's better if you have some kind of central monitoring system, but this is just for the demo. So you see, I'm just looping around and inserting data from DMX accession and DMX request into DBA database. And then I wait 10 seconds between each collection. There's also a question here about the retention of query store. So yes, you can configure a number of days you want to keep the data. Okay, now let's. So now I just abort this query. So let's pretend that this was timeout, and now I want to find it in query store. And let's say that in the incident I got, we have information about application name, the host name, maybe login name, and of course the timestamp, but we don't know the exact query. So let's see how you can do. Okay, so what I do here is that I am using this monitor data that I'm collecting. You see from my DBA database here, DMX accession, DMX request, and then I filter on the information I have. I had a login name, I had a host name, and I had a program name, the application name. And right now I'm just looking for the last minute, but this could of course be any point in time. And now we see here that I actually have two snapshots here. So you remember I collect the data every 10 seconds. Okay, now let's see if we have what we have here. Okay, so here we have the statement SQL handle. So let's try to use that and go into Query Store. So you see here, I'm just joining Query Store query with Query Store text. And then I take the statement SQL handle and also the statement context ID. So it's already the right one here. And then I try to find the query. And now we see here, query ID 10. And what you can do then is that once you have the query ID, you can go in and have a look at the plans. And you can look at, so out here we have the plan in XML. We can also look at runtime statistics. And we can see that here is the one. Okay, one execution here. And we can see there was aborted. And we can see we have information here about, durations, CPU time, and so on. And for each of these metrics, we have the average, the last, min, max, and so on. And if you're on 2017 or higher, you also have the weight statistics. And how they do it is that instead of the normal weight types, they have something called weight categories. And that is, I think there are about 20 of those weight categories. And that's because there's so many different weight types. And if they're going to store all this, broken down by all the weight types, it would be like too much information. So that's why the SQL Server team came up with this weight category thing. So they're like bundle together the different similar weight types. So you saw that we had an incident. We did not know which query it was. We only have information about the host name, the application name, and so on, and the timestamp. And then by using this monitoring data from the DMX request and DMX accessions, we were able to find the query ID. And then we could go into Query Store and have a closer look at it. And of course, now I'm showing the script, but you can also, of course, use the GUI here so that you can go into Query Store here, track queries. And then you can type in this query number 10. And now we can see here, we can see there's no aborted or cancel executions. So the square ones, they are cancel executions or aborted executions. Okay, any question about the demo? Okay, let me proceed here. So another thing to be aware of is that sometimes what can happen is that, let's say that you have an incident going on, something is timing out, and then you want to look at it in Query Store. But before you really get to looking at it in Query Store, then maybe some DBAs or maybe some developer, they also start executing the query. And what happens then is that because the real application and your DBAs or developers using Management Studio, they often have different set options. And when a different set options, then this column that we were looking at before, this context settings ID, they will be different. And because of that, it will actually be different query IDs in Query Store. And that's why it's important then to actually look at the right one. And one way of doing that is to correlate the data with DMX accessions and DMX requests like we were doing before. Because then you know that you're actually looking at the one coming from the application and not the one from your DBAs or from your developers. Okay, so this is mostly for reference, but I just want to highlight a few things. So we saw before that we have the Query Store query text as one of the tables in Query Store. And the other one for queries is Query Store query. So this is a little bit important because we have then in the Query Store query text, we have a query text ID, that's the primary key. But what is the unique key? Okay, the unique key, that is, you can say, a hash of the text, and that is the statement SQL handle. That means that if something in the statement, even the smallest thing, is changing, then you will get a new query text ID. And now let's look at the queries, the Query Store query. That's a bit more complicated. So here you have the query ID as the primary key. But what is the unique key actually? Actually, there's like 5 different columns that makes up the, you can say, composite unique key. So we have this query text ID, as we same as up here, the context ID, context settings ID, as we were looking at before, the object ID, like for example, object ID for a store procedure or a function, and a few more here. And the important thing to be aware of is that if any of those are changing, then since this is unique key, it will be a new query ID. So for example, let's say that you have a store procedure and you drop it and you recreate it without changing anything. Then you will get a new, then it's a big chance that you will get a new object ID. And because of that, it will be a new query ID. The same thing up here, if you're only doing a very small change to the query, maybe just some formatting or whatever, then you will get a new query text ID. Because it's a new query text ID, it will be a new query ID, and so on. And for the plans, we had a plan ID, that's the primary key. And then there's something called the unique key here is the query plan hash. That is the hash of the plan, together with the query ID, of course. Now let's see how this really makes a difference. So some common issues here with queries, and also that also affects plan forcing in Query Store. So I was mentioning before that, let's say that you have a store procedure, you're dropping and recreating it. That's where then you get a new object ID. Because of that, you get a new query ID. And what does this mean? Let's see if I can move this here. Okay, so this means a few things. One thing is that if we're looking at some kind of history, is that you had some, maybe you'll be running with one object ID, one query ID for maybe a week, and then it was dropped and recreated. Then of course you will have some history on the old query ID and some history on the new query ID. And that makes it a bit more difficult to look at things in Query Store. One thing is that let's say that you have actually forced the plan. Query Store has also the ability to force plan. If you have a good plan and a bad plan, and you have forced the good plan. Okay, once it gets a new query ID, then there's no plan forcing anymore because it was the old query ID that had a plan forcing. So there are some things to consider. And the same thing, of course, if there was a small modification to a statement, then you get this new statement SQL handle, a new query text ID, new query ID, and the same thing happens. So this is just the design in Query Store, just how it is, but it's something to be aware of. So another thing here that is maybe not so well known, but we ran into maybe a year ago or something in Saxo Bank. So there's something called a batch SQL handle. And that caused some problems. So what happened was that we had one query that where we were having some problems, and we had forced the plan for that one. And that fixed the issue. So it was running good for some weeks, and then suddenly we started having the same problem again. And then we were doing some investigations and also was talking to Microsoft, and then we found out that we actually got a new query ID. And the reason for that was that suddenly this is something called the batch SQL handle was different. And batch SQL handle was one of the columns in the unique key. So why had that changed? Well, it turns out that for store procedures, if the store procedure is referencing a temporary table or table variables, then actually database ID, you can say, is included or depend on the batch SQL handle depend on the database ID. So, and after the failover, there was a different database ID on the database, and because of that, we got the new batch SQL handle, and because of that, a new query ID. And then the plan that we had forced, that was forced on the old query ID, not the new query ID. So then was like had to force it once again on the new query ID, and that fixed the issue. So this is just something to be aware of. Any questions on this or the last few slides? And this is only an issue for if you have store procedures and if they're accessing temporary tables or table variables. So it's a little bit of a special case, but it's important. So one thing here is that you might have heard from Microsoft or others that Query Store is very good to have when you're doing some changes to the compatibility level or the cardinality estimator. So the idea is then that, okay, you enable Query Store and you do that like some time before you're going to do the change, so that you're like building up some history of plans in Query Store. Then you do the change to the compatibility level or the cardinality estimator. And when you change the compatibility level, you get a lot of nice new optimizer improvements. And most of the time, it just improves performance. But sometimes there can be some cases where maybe you hit some performance regression. And then the idea is that after you do the change, then you can go back and force some plans. So let's say that you had one query that was not having good performance after doing this change, then you can go back and look in Query Store and you can force one of the old plans. And it's really good pattern to follow. But because of these things that I mentioned before, there are some things to be aware of. And that is when you change these things, compatibility level or cardinality estimator, you should not change other things at the same time. For example, if you do code changes at the same time, as you saw before, then you get totally different query IDs. And that means that this plan forcing thing is not working anymore. Same thing if you want to move to new servers, then it can also, you can get new database ID, and because of that, new query IDs, and again, plan forcing is not working. So a really good pattern to follow to enable a query store or already have it enabled when doing these changes, but beware not do any other change at the same time. Okay, now we're going to go in a little bit to the different tools that you have to look at the query store data. So we saw before that we have the management studio. There is this one. I think the most useful one is this one that's called top resource consuming queries. So now this is just one query on my computer here, but then you can see. So let's see here. So now we select the query here, and then here you can see the different plans. This one only had one execution plan, and then you can see the plans down here. And if you wanted to force a plan, you can just highlight it and then force the plan. What you can also do is that you can run your own script using the query store catalog views. We're looking at some of them before, and that's of course a bit more flexible than what you can do with Management Studio, as you have more option to show it as you like. Then we also found that Power BI and also Excel Powerpivot is very powerful for analyzing the query store data. And in this example here, I'm just going to connect Power BI and Powerpivot directly to like the database. Can of course also do it more advanced, so you collect the data maybe every night or a few times a day from all your production database into some kind of central database, and then run the Power BI there. But in this case, I'm just going to do it simple. So let's see here. Yeah, I'm going to show a few slides first. So this is what I was showing before, the Management Studio interface. So here you can see that in this example here, you see there are round ones, there are the square ones, and there are the triangle ones. So the round ones are successful executions, the square one are aborted timeouts, and the triangle ones meaning that there's some kind of exception. And here, this is just another way of looking at it, but if you want to see the top resource consuming queries, you can also use it. Use a script like this. Okay, so let's go into the demos here. So I was going to over to a different computer here. Can you still see my screen?
Yes.
Okay, that's good. Okay, so what I now have is that, let me just open Management Studio here also. So I just have a local database here, and then I connected Excel, Powerpivot, and Power BI to this local database. Okay, let's see here. Okay, while this one is loading here, let's start with the Power BI. So here I just been doing it in Power BI Desktop. Of course, you can publish it also to the Power BI in Azure, but this is just in Power BI Desktop. So what we're looking at now is, you can say, a bit of the same thing as in what you had in Management Studio, this top resource consuming query. Let's see if this one is loaded now. Okay, so this is a database that I prepared for the past data community summit a few months ago. So let's, yeah, and it's basically a monitoring database, a database with monitoring data. So let's see here. Now you can see here that in Power BI, we can also have this top resource consuming queries. So this is basically the same thing that you have in Management Studio. We can see there's one here, queries 57. That's the one that seems to be using the most resources. Down here, we're looking at the overall resource consumptions, all queries in the database. And we can see it hour by hour. And the hours here are the query store intervals. So let's see what more you can do. One thing is that if you want to see the exact query, you can just hover like this, and you will see the query. Now maybe the question is, okay, so this one has been using most resources for this period here. It's about 2 weeks. But it might be some queries are using a lot of resources all the time, and some maybe is only doing it maybe in a batch job in a night or whatever. So what you can do then here is that you can see link together those two visualizations here in Power BI. So you can click on it like this, and then you can see query 57. This is actually the pattern. This is the little bit darker blue here. This is the resource utilization only for query 57. And the lighter blue, this is like the total resource utilization of in this database. So you can see that this query 57 seems like it's being executed all the time, you can say. So let's try to look at another one. Or maybe, how about this one here? Oh, this one is a bit different. This one seems to be some kind of job that is only running in the night. And here we also got the name of the store procedure. So you see, this is quite nice for correlating the data. And what you can also do is that if we go back like this, is that you can look at it from the other point of view. Is that, let's say that you have 1 hour where the resource utilization was really high. Okay, then you can just click on this one here. And now you get the top 10 queries just for this interval here, just for this 1 hour interval. Now you see there's another query here that's in the top. Or maybe you want to have two, let's say, for example, this period of 3 hours, maybe where the resource utilization was really high. What was using the resources then? So you can say that you have a little bit more flexibility here than in Management Studio to make the reports as you like. What you can also do is that, let's say that we go back like this, and you want to have a little bit more detail about this query ID 57. So what you do? You can actually do like this, and you can go into another report. So there's still, for those of you not using Power BI, they have this nice feature called drill through that you can use to connect reports together. So now I click on this one, and now you see here that I get into a different report, and only on this query ID 57. And here I can see hour by hour, I can see how many executions. I can see if there was any aborted executions. And then I have the average durations and CPU and so on here. Let's see what more I added. And you can of course add just what you like here. So, and this is just to show that, yeah, you have the query store data and you can use the Management Studio interface it, and it's very nice, but you can also do your own things. That can be very powerful. So now let's see how it looks for the time here. I think we have time. So let's have a bit closer look at how to do this. So if we go then into Query Store, we can see here that, let me just move things around here. So here we basically have all the different tables in Query Store. And we can refresh it and we get in the latest data. And we have the relationship in between. And yeah, if you haven't used it before, it's very easy. You just go in here, get data, SQL Server, and then you put in the server name, database name, and the query, and so on. And you can also look at the data like this. Here we also have the different catalog views in Query Store. So, and we have used this a lot for, you can say, ad hoc analysis when we're having some critical incidents after not so much in the incident situation, but afterwards to analyze the data. Okay, now what about Excel Powerpivot? So you can say that Power BI is very strong in having this kind of dashboards, but Powerpivot is really good for having the pivot tables. So what I've been doing here is that I'm looking at the same data again. I'm looking at it, you can say, here we have all the different queries. Here we have the dates, day by day. And we're looking at, let's see here. So we're looking at total durations. So we can see here, day by day, which queries are using the most resources or has the highest duration. And you can also drill down like this. If you want to see the exact query text, you can just drill down. And let's say that you wanted to look at something else. Let's say we want to look at CPU, for example. Okay, then we can just do like this. Okay, now we have it by CPU instead. Or if you want to, now we're looking at day by day. Let's say that you have one day that is we had a big incident. Maybe you can filter on the date, and then maybe you can look at it hour by hour here instead. So there's many different ways of doing it. Or maybe you want to get an overview. Okay, where do you have the most, which queries do you have the most timeouts? Then you can see here again, day by day, you can see which queries having the most aborted queries. Or the same thing with exceptions. Now it seems like there's only one query having exceptions here. But yeah, it gives quite a nice overview to see over time, what is different, for example, today compared to last week. Which queries is timing out now that was not timing out before? Maybe it's related to some change, whatever. And you can also look at the weight statistics. So I said before that in 2017 and higher, you also have the weight statistics. So here we have just grouped together by the weight statistics. And for example, here we can say we have the weight category locks. Okay, So what is, which queries are waiting the most for locks? So this is also quite a powerful way of analyzing it. And if you can of course use filters in different ways, and so let's say that I'm only interested in certain type of let's see. Let's say that I only want to analyze, let's say latches, for example. Okay, then I only look at that. And for those of you who not been using it, I would just look a little bit here also how you're doing it. You go into this one here, manage data model. And this is, it's like, you can say it's like a database inside Excel. So it looks very similar to Power BI. And here again, here you have all the tables with the relations and everything. And it's very easy to, if you want to, get one more table just from database SQL Server, and then what's the server, what's the database, and so on. Okay, let me go back to my original computer here. Any questions about the tools here, Power BI and Powerpivot, and how you can use that with Query Store? So this is just the same thing again here. Yeah, and here are just the steps to do it. I think we have been showing all this. And the same thing for Powerpivot, it's mostly for reference. Okay, so I have a few more slides here. I put as bonus slides because I don't know about the time. Okay, so there's a question here. Have I tried any other interesting visual apart from those you used in the demo? Yes, in Power BI, I have used the one that is, what is it called? Let me just go into Power BI and have a look what it's, I'm not sure what it's called. So I can say that what we have been building in Saxo Bank is that we are collecting data from all our production database, the Query Store data from all our production databases into central database once a night. And then we built the Power BI on top of that and publish it to Power BI in Azure. And then we made that available to all developers and developers and DBAs and whoever is interested. And that's been very good way of very useful. Okay, let's see this visualization here. Okay, while this one is loading. Okay, so one question here, how to compare query store data from two different databases, like dev versus prod. I've not been doing anything with that. I think it's possible, but one thing is those query IDs, they are, so they would be different in different environments. So you would need to compare, on something else. You need to compare on, I would think, let me see, go back here a bit. I think that if you want to compare across environment, somehow you need to compare on things that is, you can say, the same. We don't know, we don't have it here, but maybe if you use this, for example, query hash, maybe you can you have to use something that's unique across environment for the comparison. Object name, maybe if you can, resolve object ID to object names. Yeah, I haven't been doing that. I'm sure it's possible, but I have not been doing anything with that. Okay, about the visualization here that I've been using. So I've been using this one here, and what is this one called? Tree map it's called. And I think what we have been doing is that we have, now I cannot show that because it contains some real database names and so on. But what we have been doing is that we have one big tree map here as the, you can say, the starting point, and then all the different production databases here. And then you will, see which databases that are using the most resources and overall in our environment. And then we also, you can click one of, so that's how we've been doing it, and try to use that to drive optimization. Try to, make sure that the databases that are actually on the top 10 are the ones that's supposed to use the most resources. That's not always the case. Okay, let's see. I had a few more slides here in the end. Yeah, I will not show the plan forcing, but it's you saw I was doing it before in Management Studio. You can also use it, do it using a store procedure. This one here, SP query store force plan with just specify query ID and a plan ID. And you can also see it inside one of the catalog views here. You can see this is force plan. And if you have any problem with plan forcing, there is a column in this query store plan where you can see force failure count and last force failure reason. Can be, for example, that you're forced to plan to use an index and that index maybe has been dropped, or there's a few other possible reasons for plan forcing to fail. But important thing is that if plan forcing is failing, the query execution will still be successful. It will not use that plan, it will use some other plan. Like in the normal, go through the normal optimization process or normal compilation process. Okay, so one more question here. So often after the SQL Server version upgrade, performance degradation occurs. Could query store be a way to analyze this after upgrading? Most cases, what Microsoft tried to do is that when you are just upgrading to a new version and not change the compatibility level, then there should not be any performance regressions. That's like the goal Microsoft is having, because you're using like the old version of the optimizer. And then, so what we used to do, and that I would say is I would recommend, is that when you upgrade to a new version, then you should not change the compatibility level at the same time, because you have like the SQL Server upgrade to new version. That is like the risky operation, because since you changed to a new version, there's no way to go back, as the format of the database format is changing and everything. So when you're doing that, you want to keep as low risk as possible. And then I would not change the compatibility level or anything that you don't have to at the same time. And in most cases, you should not get any performance regressions then. And then maybe could be a week later or something, then you can change the compatibility level. And when you change the compatibility level, it could be that you have some queries that is getting performance regressions, and then you can go back and enforce those plans using Query Store. So yes, you can do that. So let's see, there's a few more slides. Here's more like bonus slides. Here's just a reference slide with all the different DMVs or catalog views. Here are all the options in Query Store. I think most of the default values are good. One thing is the size of the Query Store. You can specify the max size of the Query Store, and by default that was just 100 in 2016 and 17. It was changed to 1 gigabyte in 2019, and we have been going in and changing it and increased it a bit to increase it to 1 gigabyte also in the 2016 and 17 servers. Other than that, I think that defaults are good for most scenarios. One thing also is that query capture mode. So in 2019, by default, it's auto. Before it was all. And I would say that auto is a better default. So we have also been going in and changing the standard on our servers to auto. And it means that, let's say that you just have a single execution, maybe in Management Studio, then it will not get collected unless it's above a certain threshold. So a lot of small noise will not be collected if you're using the auto. And now I think we're running out of time, but if you have any more questions, please feel free to, you can write them here for a few more minutes in the chat. Otherwise, please feel free to send me an email. Okay, thank you for attending the session, and have a good day here at Data Saturday.
Thank you very much, Ola. If you have some question.
Yeah, if anyone, if there's a bit more, if there's some more time, I mean, you can unmute and ask some questions. That's also, I'm not sure, can attendance just unmute or how is it working? Or do I need to do anything?